In section 4.5, use the slope-intercept form of an equation of a line. We're going to finish off the last two sections. Use slope to identify parallel lines and use slopes to identify perpendicular lines. Part F. Use slopes to identify parallel lines. First, a little background on geometry. The definition of a plane is that it is a two-dimensional object that extends in both directions forever. Examples include the xy plane, which is all the points a, b, where a and b are just numbers. Planes are flat surfaces, and you can see other examples in GeoGebra's 3D graphing calculator. By entering y equals 4, or x plus y plus z equals 1, or entering the plane 3x minus 4z equals 2. I want you to go to GeoGebra and enter one or all of those. Let's enter y equals 4 first. Go to GeoGebra 3D Grapher, y equals 4, and we can now see that this indeed is a flat surface on the plane y equals 4. The second plane we want to enter, x plus y plus z equals the number 1, looks a little bit different. Now the plane x plus y plus z equals 1 is a little bit different than our first plane. And this last equation, 3x plus minus 4z equals 2, also defines a plane. Now in three-dimensional space, lines can either intersect, be parallel, or skew. On GeoGebra, you can search parallel versus skew lines, or on the PDF, follow this hyperlink to activity. If we look straight above at this graph, it looks like we have one line intersecting two other lines. But looking in three directions, we see that this line passing through the points E and F does not intersect either of these two lines, and it's not parallel to them either. In fact, this line is skew to the other two lines. While these two lines are in the same plane, they do not intersect and are therefore parallel. Inside a plane, for example the xy plane, which we deal with a lot, lines cannot be skew. If two lines do not intersect, then they must be parallel. In a plane, if two lines have the same slope, then either the lines are parallel or identical. And if two lines have different slopes, then the lines must intersect, that is, touch. We can see examples of this in parallel lines and slopes. Line F and line G have the same slope, 1.7. And we can also tell that they are parallel to each other. They never touch. No matter how far we can zoom out, we'll always notice that these two lines will never intersect one another. While this line has a different slope, it therefore must at some point intersect with these other two lines. And in fact, as we go down, we notice that it'll intersect here and also here. The last thing that we can see is that perhaps this line, you may think, would be parallel to my first line. But in fact, it's the exact same line. So two lines that have the same slope can either be parallel to each other or actually be the same line. Now we don't want to graph and eyeball each pair of lines. So to determine if lines are parallel, we can change the linear equations to the same form and compare their slopes and intercepts. In example 27, are the graphs of these linear equations parallel, identical, or do they intersect? You can pause here and try it on your own. Changing this equation into slope-intercept form, y equals negative x plus 1. My slope on both of these is negative 1, while the first line has a y-intercept of 1 and the second has a y-intercept of 3. So these two lines are parallel to each other because they have the same slope but are different. You try 43. Are the graphs of these equations parallel? Pause here and then compare your work with mine. I changed the first equation into slope-intercept form. First I subtracted 4x from both sides. Then I divided both sides by -3. Then I simplified. And I noticed that here my slope was 4/3, but in my other line the slope was -4/3. Therefore these two lines must intersect. In You Try 44, find a pair of equations that are parallel, identical, and find a pair of equations that are intersecting. Pause here. For You Try 45, do the same thing. You may want to label these equations 5 through 8. Here, I solved each equation for the variable. Then I noticed that equations 5 and 6 were parallel to each other because they had undefined slope. They're both vertical lines, and they also have different intercepts. Equations 7 and 8 were identical. They are horizontal lines that have intercepts of y equals 2. We could find two lines that intersect each other, such as 5 and 7, or 5 and 8, or maybe 6 and 7, or 6 and 8. Each of these are pairs of intersecting lines.